Hello everyone, welcome to Design and Analysis of Algorithms. In this lecture, we'll learn about my favorite problem, knapsack problem. Knapsack is one of my favorite problems. In this figure, we see a knapsack which was given by my advisor the day I joined IISc. And many of my research papers are based on knapsack problem. This is a list of papers on knapsack problems which I have had in recent years. And as you see, even the knapsack is mentioned in the course comics. So we'll go a bit deep into knapsack and we'll have seven part of this video, of this lecture. First part will contain introduction and the problem definition and other things. Second part contain the variant called fractional knapsack and we'll see a greedy algorithm. Third part will contain unbounded knapsack and remaining four videos will contain 0-1 knapsack. The first two of them will contain two dynamic programming based algorithms and last two will be advanced topics on approximation algorithms. So you can skip the last two, but first five are interesting and important for DA. So let's start with this problem of knapsack problem. Think that you are going to some exotic location like Lakshadweep and you're packing to travel. This is a very common problem. You have many stuffs to pack in your suitcase, but you have some restriction. Maybe suitcase has 23 kilogram weight restriction and some items are heavy but not so important. Maybe winter jackets for this travel. Some are small but very high priority, sunglasses and sunscreens, but some are maybe in the intermediate case. So your goal is to pack the maximum valuable subset that you can pack within the weight constraint. This is a question which we find often in our life. In fact, there's a quote that you really understand what is important in your life when you start packing. And there are several, this is one of the classical problems studied by Karp and classical NP question, 0-1 knapsack problem, which we'll define later. But there are multiple textbooks on this topic. And let's start with the problem definition. So we are given n items, A1, A2 up to AN. And each item AI or ith item, I'll also use I sometimes, has size Si and profit Pi. So each has some size and profit. And you have a knapsack, a bag of capacity B. And we're assuming all these numbers are integral. We'll see later why this is important. I mean, you can also have rational number, but this B or SI or PI will be part of our running time. And we'll talk about this in more detail at that time. Our goal is to find a subset of items such that two things are done. One, it should satisfy the capacity constraint. The total weight or total size should not cross B. So I'll use size and weight interchangeably and profit and value interchangeably. And subject to this constraint that they are satisfying the capacity, I want to maximize the profit. Now there are several variants. We'll study three variants. So let's take three examples. Think of this that Charlie and the Chocolate Factory Willy Wonka movie. There, Willy has a set of chocolates. You either select the chocolate or you don't take it. You cannot take it fractionally, and each chocolate is unique. You cannot take multiple copies of same chocolate. You can only take one of them. In that case, it's 0-1 knapsack, where you have items, but each item can be taken either completely as 1 or not, which is 0. The other end is fractional knapsack, where the items can be broken. Think of when Sam is packing for Frodo for the journey in Lord of the Rings. Then Sam was taking some bread, some cheese, but these items, depending on the space, he can put a part of the item. He does not need to put the entire cheese. He can cut it, maybe half of the cheese or 1/3 of the cheese, and can still take it. That's fractional knapsack, where we are allowed to cut items. And third item example is unbounded knapsack. Think of Buffet, the scene from Three Idiots. There, people when they're going, they can opt for the most valuable items many times. Maybe gulab jamun, they will take multiple times. It's a very valuable item, you can take multiple times. So in unbounded knapsack, there is no constraint on how many times an item can be taken. So there's three different variants, and we'll see they're also quite different. The solutions can be quite different. So let's look at one example. In this example, the knapsack has capacity 10 kg, and there are three types of items. Cherries, which are each unit of cherry is, let's say, packet is 3 kg and price is 360 rupees. Then pineapple is 6 kg, one pineapple, and the price is 600 rupees. And watermelon is 8 kg and the price is 880 rupees. So per kilogram, if we look at the price, one cherry is most expensive, 120 rupees per kg, and then watermelon 110 rupees per kg, and then pineapple 100 rupees per kg. Now, if you look at three problems in fractional knapsack, if you think the optimal solution what will happen is you will take the most costly item as much as possible. So cherry, 1 unit, 3 kg. But you cannot, there is only 1 unit of items. So you cannot repeat the same item. So now you have to take from either pineapple or watermelon. So watermelon is expensive, 110, more than 100. So you will take it for, let's say, 7/8 fraction. And that will already take care of the size. It will become size 10 because you're taking 7 kg of watermelon and 3 kg of cherry is already present. And the profit will become 360 for cherry, and for 7 kg, you pay 770 for the watermelon, 1130. In case of 0-1 knapsack, we cannot take the watermelon because it is exceeding the capacity. So I can take only the pineapple. So that in that case, size becomes 9. It's not completely filled up. The knapsack cannot be completely filled in this case, but the profit becomes 960. In case of unbounded knapsack, we can actually take multiple times the same cherry. So 3 times we can take the same cherry, and then that case size will become 3 times 3, 9 kg. And the profit or value we are getting is 360 times 3, which is 1080. So we see the solutions can be different and the values can be quite different. So we'll see in the next video about fractional knapsack, which is the easiest problem among these three. And then we'll talk about unbounded knapsack. And finally, we'll talk about 0-1 knapsack. Thank you.